All right. Hello, everyone. My name is Frank Dees. I am the Riot program lead for Wilson, North Carolina. Welcome to the Riot Lunch and Learn, the place where we highlight Riot's sponsors. Today, we have us presenting Germán and Wouter from Sentos, speaking on electronic product scaling made easy. So just a couple of quick reminders before we get started. First, this event is being recorded and will be posted to Riot's YouTube channel and uploaded to the meeting page where you registered for this event. If you have any questions throughout the presentation, I'll be watching the chat box, and then at the end of the presentation, we will do Q&A as well. If you would, please keep yourself muted throughout the event and hide your camera as well. And with that being said, I will hand it over and we'll sit back for a fantastic presentation.
Okay, Frank, thank you very much for the introduction. Also, thank you very much for the space. I'm also thank you to everybody that's joining us. I hope you can find this time useful and you can enjoy it and you can learn a little bit more about scaling and electronic products. Our purpose here is to share some thoughts, learnings about well, from what we've done in scaling other electronics products, and we think it can be useful, and I hope you can, the ideas that we can share, also some mistakes that we did, and you can avoid them in your own process. So yeah, to get started really quick, I'm Germán Suarez. I'm Venezuelan, but I'm based in Colombia. I've been living here for 10 years now. I'm a telecommunications engineer, and also I have a master's degree in business administration. I've been in the world of IT for 16 years, and we started Sento in 2015. I love technology. I love innovation, and what I like the most is how can we apply them and improve things in other clients, improve things in the world in general. Wouter.
Thanks, Frank. Thanks, Germán, both for the intros. My name is Wouter Popman. I'm also not from Colombia, based in Medellin, but I'm originally from the Netherlands. My background is in supply chain management. I've always worked in supply chain management, principally with the big food producers in the Netherlands, or let's call it beer producers. Heineken, probably everybody knows it. So I went from big multinationals in the Netherlands to a small electronics startup in Colombia. So quite a change, but a very good one. And I really love helping other startups scaling their electronic products. So I'm really enjoying that, among some other things here in Colombia.
Okay, so why are we here today? Or first, we think we are living in a really interesting period of the history where we can develop and scale electronics products easily than ever. Now we have more ecosystems around prototyping. We have technologies like 3D printing, where we can develop mechanical parts without a lot of setup, with a lot of tooling, investment, really quick. We have simpler sourcing of components, a bunch of websites, distributors that have available different types of modules, sensors, communication parts, a different set of pre-ready components that will accelerate the process of having an electronic product ready to the market. Also, we have easier access to capital, crowdfunding, Indiegogo, Kickstarters. We have venture capitals with more flexible and dynamic investment methodologies. So all these factors are making easier for small companies, entrepreneurs, to develop electronic products. Now it's not just a thing of the big multinationals with a lot of money available for investment, for development. Now almost anybody with a small sum of money can start prototyping and can start testing things. But it's not just developing a prototype. Imagine a startup with a small team with really strong in engineering or in electronics development. But when it gets better, when it gets bigger, this operation, you will have to develop more skills, logistics, operations, supply chain. So it can become very complex. So developing the prototype can be, now it's easier, but scaling till having a mass production, a product ready to market, is still very complex and very challenging. From prototyping to mass production, you will face different challenges. Operation will become more complex. You will have demanding cash flows to produce bigger batches. You will have to manage bigger inventories. Then you will have to start thinking about where to put them, how to move them around the different cities or different markets. You will have to start thinking about international logistics, tariffs, taxes, and logistics operations. You will have to start thinking about quality and compliance. Now it's not about a prototype that if it breaks, nothing happens. Now you will have hundreds of devices on the market and what happens if half of them fail. And time to market. All of these complexities will impact at the end how fast you reach in the market. So scaling a product is not just about it's not just about engineering, but it involves operations, logistics, and many other processes. So that's why we're here, because we want to share some learnings and thoughts about our experience in all this process of having taking a product to mass production, and we want to explain it to you like in the stages of a traditional development of an electronic product. So we'll start with prototype, with minimum viable product. Then we'll have a scalable product. We will start doing small and medium-sized batches of production, and then we will end with the mass production. There's where we all want to go. First, you will have to focus a lot on the engineering, and when you already have the scalable product, then you will have to start thinking about operations and logistics. They will be key for the success of your business. In order to have like a practical experience here, we will take two products that we developed with a client called Asymmetrics. Asymmetrics is a company focused on analytics for animal farmers, for poultry and pigs producers. With them, we developed two products. One of them is the Smart Weight, which is a mechanical device that will measure automatically the weight of the birds in the farms. They will jump in on the scale, and it will start calculating the average weight of the batch. And the Pig Vision is a camera-based device that will take pictures of the pigs from above, and with image processing, it will estimate also the weight of the pen of pigs. So these two were considering the environments, they were pretty challenging. So I think it can be very useful to share some of the learnings of the experience that we had through the process of development and scaling them. So first, what we did. I'm going to tell you what we did and what we think that each stage should cover. So first, we went to the farms. We are not animal specialists. We are not veterinarians. We are engineers. So we went to the farms and we spent there weeks, and we spent whole days watching the birds, the pigs, understanding how they move, how do they react to an object, how high can they jump. So we focus on understanding very well the behavior of the animals. Our prototypes didn't have any kind of communication. We just wanted to test if we were able to get a useful weight. The lifespan of the device was 8 hours. I mean, we would go to bed and we would come in the morning and it was already not working. We didn't think about robustness at that time, or reliability. One thing that at this point we know that we did wrong was we focused too much on the animal and not the user, the farmer. You have to be careful with the user. He's the person who's going to be interacting with your product. You have to make sure he's willing to use it. He's willing to maintain it. He's willing to take care of it. So at some point we had a lot of problems because we didn't get involved enough the farmer in the usage of the product. So what we think is important during the prototype, understand very well the market, the user, the environment, speed. Don't think about perfection. It's better done than perfect. Detect what functionalities generate value. I mean, and to know that, you have to understand very, very well the market and the user. Who's going to be your end user? Who's going to be interacting with your product? What is not a priority? Perfection, cost. I don't care about cost. I want to deploy it really quick. Automation or sophisticated functionalities. If you have to give a report to the end user or share some information, do it manually. Don't build something complex that will do it automatically and spend 1 month doing it because you're still not sure what's the value, or I mean, you're not sure what the customer's gonna use more. So recommendations, key recommendations from our experience. Start from existing products or platforms in the market. Don't invent the wheel. Use development boards. Use something that is already working, and then you have to adjust something, but it won't look great. It will be more expensive. It will be efficient, but it's already working. And you only need to do a small improvement or change in the design. Learn and copy from others. Study your competitors. Study your market. Know what other people have done before you. Try to get as much information from outside that will make you not avoid you to go through the same mistakes, and spend as much time as possible with the environment and the market. If you're not completely sure about what the market needs or what you're solving, then you will end developing something that nobody's going to use. Then we said, okay, we are able to get some useful weights. They are close to the reality. We need to test this product in a bigger environment, with more farms, right? So we say, okay, we're gonna deploy this device in 10 farms, then in 20, then in 30, then in 50. We didn't think we were gonna have a design for 60 farms. No, we first think about doing it in 10, then in 20, then in 30. And in each iteration, we would improve something in the MVP. So we think, okay, we're gonna have a couple of 100 devices, then they will have to work a little bit more than the prototype. So in the best case, it would work for 6 months. So then here you start thinking about a little bit more about it has to work for longer. It doesn't have to be like industrial grade, but I have to be able to test in a bigger environment without going crazy about doing maintenance on each device. Not sophisticated, but robust. We didn't look outside, and limited remote diagnosis. Those two, the last two ones, we would do it differently, or we are now doing it differently, because we didn't take in account some designs from the market, from scales in general, and later in the design process we had to change it because they were there for a reason and we didn't consider them before. Limited remote diagnosis, we didn't think about, okay, well, if it's broken, how can we help diagnose the what's going on, or how can we work together with the farmer to know what's going on. We didn't have any of those functionalities, and that demand us a lot of support. So in the MVP, you're thinking about these quantities are suitable for this case, but they can change depending on the kind of product. So, but in this case, we thought it was going to be like from 25 to 250 devices. So here you're looking is to replicate what you got in the prototype to test it in a bigger scenario, and detect for different clients what works and what doesn't. It has to be more reliable than the prototype. The client must be willing to pay. At this time, you have to ask them, hey, this is a prototype. This is gonna fail at some point. Are you willing to pay for this? I mean, if there is not like a willingness from the client, then you have to review what you're doing and what you're trying to solve before going further. Basic support process, you have to make sure you are able to provide some support to the deploy units. So you have to find a way to somebody from your team, or somebody from or somebody responsible of providing support. Also, cost and efficiency is not a priority here. Time is the priority. So don't think about making it more efficient. If you reduce, I don't know, if you reduce $20 in a 100 batch, that's $2,000. I mean, how much would you have to spend in engineering to reduce that cost? And time is more precious here. So focus on deploying really fast. Recommendations. Select very well the clients where you're gonna test your MVP. They have to be willing to help you with the support. They have to put some resources to make this project work. But at the same time, you have to find clients that are very critical and help you improve and give you a valuable feedback. Use development model platforms. Think about optimizing in the future. Basic remote management will help you. Will solve. Will let you sleep during night. If you're able to reduce the support and visits on site. And now, once we had like a couple of hundred farms in operation, we were struggling with the support, because we were having, I would say, like 30% failures every I don't know, every 15 days. So it was, from the support, from the operation, it was really demanding. So we said, okay, we have to migrate to something that's more scalable. That's something that will it would reduce the failure rate from 30 to 2%, because otherwise we will increase our operation demand. So what we were clear at this point is that we understood very well the environment. Farms doesn't have reliable electricity. Cellular coverage is really poor. Farmers are not very technology oriented. So you have to consider all of that to make sure you are designing the right product that's going to be suitable for mass production. So then we started designing, like, now from scratch, not totally from scratch, but making sure the functionalities that we had, that we were going to have, were the right ones for the environment, trying to lower down the cost. But at this time, we look for help. We look for specialists from the mechanical design, from electronics, from compliance, from communications, and we ask them to help us improve the design, and that helped us a lot to move really fast. All the investment that we did there at that moment saved us a lot of money later. So here we focus on the robustness and the operation. One key functionality, if you're going to deploy multiple devices, is to have over-the-air functionalities. Otherwise, you will have to go visit every site. You will have to be able to diagnose remotely, upgrade firmwares, update anything related to functionalities without the need of going on site. Here, sometimes when we think about scalable, now we're thinking about 10,000 units. Don't think about 10,000 units. Think about the first 500. Because the product will be evolving all the time. It's not an ending process. It's a never-ending process. And that's the key. If you want to succeed, you have to keep improving it in each iteration. So you don't have to expect that in the first batch the product is going to be perfect. It's going to be enough to scale. Like, you have to define as a percentage of failure, and you have to be able to reach that percentage in order that you guarantee that you're going to have a viable operation. It has to be easy to deploy and maintain. A standardized production and process and bill of materials. At some point, we had a product that was technically ready, but we had to improve how we were assembling, because otherwise we will have a good design, but not the suitable assembly process, and we will keep having a lot of issues and problems on field. Think about weight, think about size, because when you scale it, you will have to move your production to somewhere else. And if it's big and heavy, it will bring a lot of logistic cost. What is your critical components? What is your, how is the market, the supply of components right now? How is it looking? You know, how is everything going with China and the lack of components, and they are increasing the prices on each of them. So you have to consider very well what components are you going to use, and how easy are they going to be, how easy will you be able to source them. So here you have to think about it's like a trick. You have to think about the long term, but focus on the short term, because you cannot expect to have the product perfect to go to the market. You will have to iterate, and it's gonna keep improving, and as I said, it's never ending. So like here, the advice is not to delay it. Try to consider the key problems or the difficulties that you will challenge, but go to the market and improve on the goal.
Thanks, Germán. For the new people that just entered, the one that was just talking is Germán Suarez. He's the founder of a company. My name is Wouter Popman, and I'm the director of operations of our company. I will take it from here from Germán. So let's assume that we've passed all these previous phases. Then you get to the phase where you go to small to medium size productions or batches, and I would call it's the ramp up dilemma. I always say you're getting too big for your garage, but you're yet too small to take your production to China, to one of the big producers in United States. I just lost the presentation.
Yeah. Sorry. My bad.
So yeah, literally we've experienced this ourselves. So I think we started with one office, then we had two, then we had four, then we didn't have any space anymore in the same office. But when we were talking with, for example, Chinese manufacturers or American manufacturers, and we said we would like to produce 250 units or 500 units, they were just laughing at us. So yeah, you're getting in a phase where you're too big for the garage, too small for those parties. So we decided at that point to solve that situation ourselves. So at that point, we constructed an assembly line here in Colombia. I can tell a little bit more about that also later. It is also a very challenging phase, let's say, in the meaning that you have to get control over your production process and over the quality, but you have to remain flexible. So that is extremely challenging because it doesn't go it doesn't go hand in hand very well. So for example, you have to standardize or create procedures for the production, but you know that production is going to change probably every 2 weeks. So it means that you have to adjust the procedures to assemble it. But if you don't have these procedures, it means that the people that do the assembly can really create a different equipment every time they make it. And if that is the case, then it's very hard to get control over quality, because if something goes wrong in the field, it's very hard to figure out what is exactly going wrong. So when I started as well, I think the guys were doing the assembly like in individual ways. They were making at a scale, for example, that Germán was showing, and they could make a lot of scales during the week, but from the outside they might look the same, but if you would open the scale, they were completely different from inside. So the soldering was different, the application of silicon, how to put the wires inside. And so, for example, how can that influence quality? Well, for example, if you don't guide well the cables within your product, it can get stuck between the plastics of your product, and it can damage the cable, and it can cause a failure. So that's just one example. But if you standardize it, you're almost sure that you can prevent problems coming from that. What else? Yes, as I said, you need to remain very flexible. I remember at the time I had to do changes to batches that we just produced, and before they were even shipped out, Germán would enter my office and say, "Hey, Wouter, we need to do another change to the same batch that we just touched every single unit of the batch, and we had to touch it again." So that, of course, in the beginning it was driving me a bit mad, but yeah, it's part of what you need to do in that phase. The quality part is also very important. Germán also already mentioned it a little bit. If you just produce 200 units and there's a quality problem, it's more or less still within your control. You will make extra cost on it for sure, but if you have an extra cost of $10 a unit, it will be 200 units times $10. It's manageable still. But if you start producing 5,000 units or 10,000 units or even more, this gets completely out of control. So this is the time where you need to get control also over quality. It doesn't need to be perfect, but let's say the low-hanging fruit quality-wise, you have to get these problems out. Very important also in the beginning. I remember, for example, that we were talking in the beginning with Flex in the USA, and we were very proud that they were contacting us and that they were interested in us. But very important in this phase is that you keep very common sense with partners that you're going to work with. if you're producing 200 units of a product that might value, for example, $200, does it make sense? And if you just think about it, to work with a company like Flex? Probably it doesn't. And if you take your design of the plastics to a manufacturer here in Medellin, and you know that that manufacturer is producing, I don't know, 100,000 units per week for a big car producer or a motorcycle producer, does it make sense to produce with them? Probably not, because if something changes in their production, like in their planning, you're sure you're going to be the last in the line that they will produce. So it's very important to find companies that are more or less the same size, or at least that are vibrating also the same kind of energy, that are willing to help startups, that like to work with startups, that maybe charge a little bit more per unit, but that are very flexible. So extremely important, not only for plastics producers, but also, for example, if you think about producing electronics in China, it's the same ball game. You can find literally every supplier that you want. You can find small ones, big ones, bad ones, good ones. Everything is out there. What did we learn from this? Germán also commented on this already a bit. The most important is speed and flexibility. So yeah, it doesn't matter if it costs a little bit more. It also doesn't make a lot of sense to get everything totally perfect, or $2 more cheap on the cables or whatever. No, you need to get it out on the field as soon as possible and get feedback from your customers, implement the feedback, change your product, put it out there again. That's much more important in this phase than cost. From cash flow point of view, I'm not sure how many of you guys have already been in cash flow problems, but for sure, if you're scaling your product, you're going to be in problems with that if you don't think about it very well. But if you think about it just 5 seconds, it makes completely sense. First, you're producing 200 units. Let's assume that you still have the same product. Then you can more or less still manage the investment that you need to buy all the electronics in China, to buy all the other materials. And then you have more or less all your cash in that first batch, but you haven't started selling yet. First, you need to sell to put the products in the field and sell it. But before you have all the money, you already have to prepare your second batch. And that second batch, if you're growing quite fast, is going to be bigger. So you need more cash to order more electronics in China or more other components. So you get in this circle where if you don't manage it very well, you're going to be stuck with cash flow for a long time. So yeah, we learned it also the hard way here. We have quite some problems in the past with cash flow, and what we see now, it just works a lot better to work with very small batches in the beginning, upgrade them steadily, step by step, and don't rush it here, because you're just putting all your cash in inventory. Germán commented already also about this one. It's the last step in, let's say, the whole supply chain, and maybe that's why sometimes we forget about it. But what happens after your product is in the field and something is failing? What are you going to do? It's something you definitely need to think about it. And when we were deploying our products, for example, in Colombia, it is more or less still manageable if something fails. You have big distances that you need to cover to go to a farm, and they're always very hard to reach. But as you probably are aware, labor cost in Colombia is not that high as in US, so it's more or less manageable. But if you take the same product to the US, which we also did, and you need to manage something in US, you need to send a technician to a farm, or you need to send a product to repair it, it gets completely out of control. An average person to repair something will cost you $25. To send the product around will cost you probably $100 to send it and get it back. So it's something that you really need to think of well, how you're going to manage that with your product. And the other one, Germán also commented on that already. Don't try to do everything yourself. You have a really great idea, but you only have got probably one opportunity to launch it well. So make speed, use knowledge of other people, and get your product sold. Focus on the sales and your client, and let the stuff, other stuff that other people have probably more knowledge about, and let them do or be done by other people. Yeah, thanks, Germán. Next one. So what did we do? This is just an example how we did it. This is not, of course, a perfect example or a guideline how we think you should do all of your products. But this is how we did it. So we said in the beginning, after traveling to US, after traveling to China, India, and we said, okay, if it's concerning a PCBA, China is just a champion in the world, price quality wise. There is no other country that can do it better than China. So let's not try to invent the wheel ourselves. We're going to produce it in China. So we're talking about the electronic board and all the small service mount components that go on top of that. But we said, whatever happens after that, it's still very small. It doesn't weigh a lot, so we can easily ship it around to another place in the world. Whatever happens after that, we probably can do it cheaper in Colombia. Why is that? Material prices are more or less comparable, but the labor in Colombia is a lot cheaper than in China. And most of the components, of course, not the very critical components, we can find it also in Colombia. So we source the PCBs from China. What we did locally is principally like plastics, metals, packaging materials, regular components that we can easily buy here. And the only things we got from outside, besides the PCBAs, like the really specific components, like, for example, Raspberry Pi, specific cameras, those kinds of stuff, we got it from outside. And we assembled everything here in Colombia. So we developed our own assembly line, and there we assembled everything. So we also we did the through-hole components. Probably most of you have heard of that. It's like the big components that those pick and place machines in China can generally not place. So you have to place them manually, solder them on the backside of the board. So we also do that all in-house. And also the whole electromechanical assembly, we also do that in-house in Colombia. And from there, so from Colombia, from a factory, we shipped everything to principally our customers in the United States. So this is just one setup, but yeah, of course, there's a lot of variance possible here. Then next phase, mass production. Yeah, mass production seems really complex. There's a lot of money involved, but I think the most important tip to give to everybody here is keep it simple. Don't make it more complicated than is needed. Mass production, of course, requires a lot of standardization. So a lot more than we did in the medium-sized batches. So for example, if you bring your batch or your product to China, and you don't have all your files completely standardized, like the bill of material, the Gerber files, the pick and place, your assembly documents, the procedures, how you need to assemble it, they will probably not even accept your project, or what is even probably worse is they let you start your project, and then if you have to do a change, they will charge you heavily for doing changes. So it's really important to have that all organized and standardized. But this is a phase where Germán said in the beginning that where you should not focus too much on cost. Now you have to focus on cost, because otherwise your product's probably not going to be viable, or if you don't focus on the cost, probably easily be copied within a few months afterwards. So for example, you have to think really well about the shipping cost, which can be a really large component, about setup costs, for example, in non-recurrent engineering, like the plastics molds, the metals that you might need for your product. So all those kinds of things, you need to think about how to get the cost down. Also important, Germán already mentioned the problems with some electronic components, microprocessors, for example, this time. Also the situations, probably you've also heard of that with COVID, that is still going on in China, that, well, with let's say very light COVID cases, they can completely shut down a whole city. So if you have a very long supply chain with a lot of components coming from China or from Far East, you're quite exposed to those risks, so that can completely shut down your production. And so what we see even more than before is that it makes a lot of sense to cut your lead times, to search where you can for things closer to home. That might cost a little bit more in some cases. So that goes against a message where say that you have to cut costs. But of course, the cost of non-availability in this phase of your product is probably going to be a lot higher. Yeah, big batches, of course. Yeah, probably don't need to explain that. But if you have that many fixed costs, like for example, the investment of very expensive molds, the more products you make in one batch, the lower the cost per product will get. So you need to make big batches to get the cost down. Yeah, so compared to the previous phase where it's really important to be fast and flexible, here in this phase it's much more important the cost and the quality and the reliability of the products. We haven't talked about this any moment in this presentation, but what is really important is to think exactly how you're going to do this image, like I showed to you guys before. Where do you get the components? Where are you going to make the product? Because this is going to determine what we say the country of origin of your product, and this determines the amount of tariffs that you have to pay if you, well, let's assume that you ship the product to the US. So if you make it in China, you at this moment you have to pay very large tariffs on importing these products to US. If you make it in Colombia, like the camera that Germán was showing before, which contains, of course, a lot of components that are coming from China. But if you do it well, and in most cases, especially if you make it in a place outside of China and outside of US, so in our case it was Colombia, you can say that it's made in Colombia, and based on the treaty that we have with the United States on the free trade, and we can ship most of these products without paying tariffs in the United States. These tariffs can easily go to 25, 30, 33%. So it's really something to take into account in determining your whole logistics. Yeah, Germán? So summary of what we just said before, but don't worry if there's after the meeting questions or things that we have not said that you're wondering about, of course you always can contact us, that is no problem at all. So a prototype is not a product. A prototype is just 20% of the product. Germán has shown you how difficult the whole journey can be from making a prototype to go to mass production. So a prototype, you're just on 20%. So we don't want to demotivate any people, but there's a lot still to come afterwards. Get as much help as you can. It will save you time and money. We always say you have to focus on getting sales, focus on your clients, and everything that has not directly to do with that, it's better to find other people to help you with that to gain speed. Yeah, as mentioned before, when going big, simplicity is your best friend. Don't get confused by big sizes, big numbers of money. You just have to keep it simple, and that for sure that will work. In the beginning, you will need heavy engineering, as Germán mentioned, but whenever you go to scaling your product to medium size or bigger batches, operations and supply chain are the most important for your product to remain viable. Focus on the short term, but know where you're going to go. I think that is also a very important advice that we can give here. Grow progressively but fast. Yeah, so you have to do adjustments to your product. As Germán was saying, you have to do these iteration process with your customers, but don't wait too long with them, or don't try also to do these iterations, those modifications to the product that you have. Don't try to make them perfect. Try to make them work. Put back your product in the field with the customers. Get more feedback. That's the way to move forward, and not getting the product perfect. And already mentioned also before, it's not about the idea, it's how you implement it. You probably, if you have a great idea, and I'm sure a lot of you guys have a great idea of a product, and it's the way how you implement it is going to determine if you're going to be successful or not. You probably have one shot, if you're lucky, maybe two, so you have to do it right. Germán.
Okay. And just to give you an overview of what we do, basically from all this process that we described, from launching, from taking some products with some clients, from prototype to scaling them, we had a lot of challenges. We had some points where we didn't have like a lot of options to grow in the way we wanted. So we developed that capacity of being able to scale a product with flexibility and agility. So basically what we do at Sento is we help you design and make a prototype and take it to a product, and then we have operations based here in Colombia where we can help you scale your product, start with small quantities, with the sufficient, with the right quality that will let you make the improvements that you will have to do while growing, being with you to help you, like to give you some advice about certifications, about quality improvements, about communication protocols, about operation models, helping you like grow your product while you can focus on your business. That's what we do at Sento. That's how, and we came up with this proposal based on our own experience in the process of scaling a product. So definitely that's something we found in many startups that have the same challenges that when they want to scale their products. And what we see right now in the market is that we have like this contract manufacturer, very old school, very demanding, like really large quantities without the right startup mindset. And that's we wanted to implement in this kind of process, like a flexible, agile attitude to help you grow progressively. I think that's the key, progressively but fast. So here's our contacts, and you can scan the QR and you will have the rest of like WhatsApp, contact, email, also our phone numbers. And yeah, we're open to questions. Thank you very much.
Thank you so much. So we've got about 12 minutes left. So if there are any questions that anyone has, please type those into the chat box, and I'll read these out to you, Germán, and let you answer these. So it looks like we've got two questions right now. The first one, it says they have a question about timing. When do you recommend actually designing for manufacture? It would make a big difference would it make a big difference when finally taking the product to mass production?
Well, I think there are two key things that you have to consider when start designing for scaling. One thing is that you have to make sure you really know the business. I mean, you are sure about what the client is willing to pay for, or you are solving the problem you want to solve, like you are doing it very well, and then you just need to improve your design to make it work better. You have to make sure that you are very clear about your business. And I would try to work like in the MVP stage as much as I can. I mean, if your operation is I mean, you still can manage it. If you're not having like a huge quantities of failures and it's becoming impossible to support those, or it's becoming too expensive, I will try to extend it a little bit more till I'm really sure about the business. If I'm sure, I will jump into it once I'm clear about that. I hope that helped.
Thank you. We've got a couple more questions. The next one, what packaging capabilities do you have experience with in addition to 3D printing?
Well, like packaging, like in housing, we also work on an interesting option is what's the name in English? Termoformado. Bowder, I need your help. Sorry.
I wouldn't know that in English as well. I will look for it meanwhile.
Sorry. Like a plastic, not thermoforming, sorry. Yeah, thermoforming, which is like a cheaper process of than injection. If it's not like a very demanding, like specialized housing, thermoforming is a really good option to start scaling. Also, yeah, from plastics. For example, here in Colombia, we have, if it's not like a big piece, you have injection where you have to build like a standard mold, but there are other alternatives where you can have like a semi-manual injection process, and those are suitable for small size housing, and it's really cheap to do them all. And if you're doing, I don't know, less than 1,000 units, then it's really interesting to start in using those types of molds of injection process.
All right, next question. How do you estimate the cost of the stages going from a prototype to small batch to medium batch to mass production?
Germán, so I take this one.
Okay.
I see the questions from Greg. Thanks, Greg, for the question. It depends a little bit, I would say, also on the phase where you are. So if you are in, let's say, in the more early stages of your product, where we said that, for example, cost is not the most important. You have a lot of options online, for example, to easily check components and compare various providers with each other. So you will get quite a good basic idea of what will my product cost. But that changes, of course, if you go to a mass production phase where you need to focus on the cost. Then it's a lot better to search more than those, let's say, the main providers that you can find, like for example DigiKey Mouser, because for sure you can find them cheaper, which can save you a lot of money. For the rest, this is one of the things where I would say, yeah, don't focus too much on this. We need to have these estimations, of course, but there's other companies that have a lot of experience with quoting, for example, plastics. They know if you need a mold or not, if you can do it with 3D or not, or with thermal forming, like Germán was saying. So I would recommend, if that, of course, it belongs to the possibility to outsource this process of quoting these types of things as soon as possible. So yeah, it changes a little bit over the batch sizes. Of course, a 3D printed part, for example, for plastics is a lot more expensive than it would be to have one piece produced by a mold. A piece produced by a mold could be maybe 100 times more cheap than a 3D printed part, but that all depends on, of course, on your product and the designs of the different parts that go in there. So the bigger the part, for example, the more expensive 3D printing will be. So I hope, Greg, that it answered your question.
Something that we have to, not for at the moment of scaling, but something that we have learned from the process of prototyping, designing, going to the scalable product, is that the effort of the testing is, I think, is one of the biggest one. I mean, the cost of testing is really I don't know, I would say like 30% of the cost of developing a product in each stage, because you have to go to on site, you have to test it, you have to manufacture a couple of prototypes, then go again, do some improvements. So when we are estimating like how long will a project take, we say that 40% of the time is the final testing, because it will require some iterations, and in hardware that's very slow. You will have to produce another prototype, another board, and so it will take 1 month or so to do a new one. So that period of time is usually long.
Very good. So it looks like we've got time for one more question. Let's see here. It says, when do you worry about intellectual property? How do you keep your manufacturers from stealing your secrets?
I don't know. I think key is, as Bauder was saying, work with reliable partners that you trust. Look for opinions from somebody, from other people from that knows the market. It's very important to work with reliable providers. We usually think about patents after the MVP, because before the MVP, it usually will take it will change a lot the design. So you have to have some kind of base architecture or structure or technology to do the patent. So before the MVP, it's very likely that you will have to do it again.
Yeah, maybe to add here, Germán, which is also helping in this part. So, for example, the pig vision that Germán was showing, which is the camera for the pigs. It is of course quite easily to make, let's say, the plastics to put the camera. Probably anybody that catches one of our products or sees the bill of material can really make it. But then still, if you would place it in the farm, it would not work, which has to do with all the algorithms that are behind it. So all the firmware that is there. So what we generally also advise is to separate always the firmware from the app providers, especially in China. And what we also see the clients that for example, let us also do the firmware in the house, which most clients do. They can, for example, how do you say that? Protect the firmware also with a key, which keeps them still in control until the last part of the firmware, where they have to put a key, and then it's ready. So there's various ways, to protect it, I would say.
Yeah, just to add, we don't share like source files with the manufacturer, just the manufacturing files. They cannot do a lot with that. We don't share like the source files from the firmware. They just have like something that they upload on the microcontroller or microprocessor. NDA, obviously, is the basics. We sign NDAs with each of our providers before sharing any information.
Very good. Thank you for all of that. Thank you for your questions. Thank you for a wonderful presentation. Again, this will be available on Riot's YouTube channel this afternoon. And if you have any other questions or comments, I'm sure you can reach out to these gentlemen. Their contact information is there for everyone. And we hope you have a great rest of your day. Thank you, everyone.
Thanks, Frank. Thanks, everybody, for being there.
Thank you very much, everybody. You have our contacts. Feel free to reach us in case you need any help in any advice or anything without compromise. Just please get in touch. Frank, thank you very much.
Thank you.
Frank, maybe one thing to add for everybody. We have been working with some companies in the Riot network. So if anybody also wants to hear their experiences, ask Tom Snyder, and he can also give you some experiences, probably from other clients within the Riot network.
Very good. Absolutely. We'd be glad to do that. All right. Thank you, everyone. Have a great day.
You too. Bye.
Bye. Thank you very much.